Hello everyone and welcome back to Project CD Chronicles, or welcome if this is your first time. In today's video, we will be covering assembly game programming and C programming once again, with a game that was written by the talented developer Fabrizio Caruso. Befana vs. Balloons, released on Epiphany Day, but for technical reasons with the channel, I was only able to, let's say, do the review this week with today's video. By the way, there's an important format, and I suggest you stay with me until the end of the video because we're going to take a closer look at the making of Befana vs. Balloons directly with Fabrizio Caruso, because through some thoughtful questions that I asked him, he obviously answered and showed us in detail what was the genesis, the construction, the programming itself of the game Befana vs. Balloons. And I believe this is exactly the type of video and document that can really enrich the landscape of C and assembler game programming. Stay with me until the end. First of all, let's go and see directly how the game is played. It's a horizontal scrolling shooter where we have our legendary, basically a hot air balloon that reminds us of the one in the Commodore 64 manual. You see, well, I'm not very good at playing it. You can see anyway that it has some accelerations and special techniques that we are going to illustrate. So this is a little bit of the game. There are a variety of different prizes that you can win, and you have to carefully make your way through a selection of gifts, each with its own unique qualities. It also includes some really interesting and innovative techniques, especially when it comes to the area of game programming for the Commodore 64. Specifically, we're going to look at what will be the multiplexor lib, which is able to handle multiple sprites simultaneously on the Commodore 64. But pay attention, the author himself will tell us about this game. Now, take a good look, more or less, to get an idea of this part of what this game is. And we will look at it piece by piece with the various questions and interviews. So, in fact, the evolution and genesis of the game. All right, let's start directly with Fabrizio Caruso. From what is his GitHub, Fabrizio Caruso, where, by the way, there are some really interesting repositories, besides 10-line conics, 8-bit, which we will briefly mention, and in particular C64 multiplexor C-lib, from which the entire construction of what is, in fact, the Befana Balloons game unfolds. And we will illustrate how he created this game. By the way, for technical reasons, I sent some questions to Fabrizio, who kindly answered me, and I will try through an audio recording to demonstrate in the various phases, so to speak, the illustration of the library and the game, a sound file that is not exactly his voice and his image, precisely to give more life to what is an interview. Also, because for reasons obviously of work, technical, and so on, it would have been quite difficult to also do directly what was a live stream. All right, let's start. Hello, Fabrizio, and welcome to Project CD Chronicles. Before we dive, in fact, into the Befana's code, tell us briefly who you are, what your computer science background is, and how you got into or back into developing for the Commodore 64.
First of all, thank you for this interview. I am a 53-year-old computer scientist who therefore lived through the golden age of the first spread of computing, when computers were called home computers. In 1983 I got my first computer, a Commodore 64, with which I learned BASIC and the rudiments of assembly. Then I moved on to other languages like Pascal and C. On the C64, I wrote some very simple games in BASIC. I dreamed of writing some in assembly, maybe with a multiplexor, but without succeeding. Then over the years I moved to Amiga and PC and continued my studies until I graduated and then got my PhD in computer science. The world of retro computers has always remained in my heart. I now live in Nice, where I work as a back-end developer.
All right, let's move on to this second question, the idea and the theme. The game has a very particular and local theme, the Befana. How did the idea of a horizontal shooter with this protagonist come about? Was it a choice linked to some childhood memory? Or did you want to create something culturally unique in the Commodore 64 scene?
The choice has several reasons. The first is the most trivial. I'm not a great artist or a musician. I had to steal the assets. I really liked Cauldron. Then, remembering the first sprite I managed to move on the C64, I was tempted to use the hot air balloon from the C64 manual, which, however, has an error on one byte in the manual. I put the two things together. I also liked the idea of a game to be released on a specific date and with little time available to develop it, the Christmas holidays. I took the music from the high voltage SID collection of Santa Claus, and the gift packages come from the game Santa's Xmas Caper.
Okay, let's get back to the C64 multiplexor CLib and the game anyway from BEFANA. So the question is, as we can see here, Flavio Web, Pascaline, and Teamwork. Now I ask you, in the project, we see the shared credits with Flavio Web, Pascaline for the demo code part, SID support, and adaptation of the multiplexer. How did the technical collaboration between the two of you unfold? And did you divide the tasks clearly? For example, you on C and he on assembler, or was there, let's say, much more cross-pollination? The actual code of the game, Befana versus Balloons, is written in C and it's all my own work, but I use ripped assets and music in addition to the multiplexer library, which is instead written in assembly. The multiplexer is an adaptation of Cadaver's generic multiplexer used in Ocean Games. The adaptation was done mainly by Flavio Web and to a lesser extent by me.
I thank Flavio Web because he helped me understand how a generic multiplexer works on the Commodore 64. The C64 multiplexor CLib library also contains another multiplexer not used in the game. This second multiplexer was written mainly by me, and it's a simple parameterizable splitter that can be used from C like the multiplexer.
Excellent. Let's continue with a very important point, the challenge of the 8 sprites. And let's now talk about the C64 multiplexor CLib library. So we know that the Commodore 64 has a hardware limit of 8 sprites, but in Befana we see the protagonist, multiple enemies, projectiles, and bonuses simultaneously, up to 21 logical sprites. What was the main difficulty in adapting a generic multiplexer for a fast horizontal scroll like this one?
The hardest part was done by Cadaver, author of the original multiplexer in the 80s. The adaptation was mainly syntactic to convert the assembly to the syntax of CA65, the assembler of the CC65 dev kit, so that it could then be used more easily from C. We also integrated into the same code the code that controls the SID tune and the code that optionally activates the 2 MHz on the Commodore 128 when the raster is on the top and bottom border. Furthermore, Flavio Web adapted the multiplexer code to also run on native C128 and not just on C128 in 64 mode and native C64. Cadaver's original multiplexer, as well as ours, is in charge of calculating the 9th bit of the sprite's horizontal position, but providing horizontal movements in multiples of 2 pixels.
Fifth question. This is definitely a very technical detail of this library, the IRQ1 sorting algorithm, and here we can look at it from the C64 multiplexer source listing. So I ask you, analyzing the source code and in particular generic multiplexor.s, which is this one, I noticed and we noticed that in the first interrupt, and I'm referring specifically to this line of code, IRQ1, you use what is an insertion sort to sort the sprite based on the y coordinate. So I ask you, why did you choose this specific algorithm? Is it a matter of stability, to avoid the shimmer, the flickering, or for pure execution speed?
The choice was made by Cadaver. His explanation, which for me is flawless, is that insertion sort is optimal when there are few position changes. If the sprites were to change position very quickly, you could use quicksort.
Now let's talk about the hybrid approach, which is also the title of the video, C plus assembly. Your engine, in fact, is a fascinating mix of C and assembly. The game logic, so enemy movement and collisions, is in C, while the, so to speak, dirty work video interrupts music is in assembly. Do you think that today, with compilers like CC65, this hybrid approach is in fact the main path for those who want to develop complex games on the Commodore 64 without going crazy purely with assembly?
Yes and no. Yes, because it is a practically possible path. There are C compilers like CiC that are much more efficient than CC65, which is among the slowest, although it's the one with the most support. You could even give up assembly entirely, or almost entirely, by using CiC. There's also the game Borderline Pac-Man, which uses 9 sprites, 8.5 to be precise, on the same raster lines, written in CiC by Camelot, the author of CiC, with almost no lines of assembly. No, at least not for everyone, because not everyone wants to program in C, preferring 8-bit assembly which is vintage and gives other satisfactions. This is understandable because if we write games for machines from the 80s, it's also because we like to rediscover how programming was done back then. I use C because it's a kind of universal assembly that I can use on hundreds of different machines.
All right, now let's talk about the main routine, specifically the synchronization handshake. So I ask you, in the main loop in C, as we can see here, we noticed a very precise synchronization mechanism. The loop waits for the multiplex done from the interrupt before proceeding and raises a flag, which is the sprite update flag when it has actually finished. I'd like to ask, how difficult was it to balance the C calculation time so that it wouldn't exceed the frame time, obviously while avoiding lag, having to wait for the assembly code, of course, to finish its work?
I don't think I'm inventing anything new by saying that I calibrated everything by changing the border color at the start of the loop and then at the end of the loop. This way I can see how many raster lines, and therefore how much time, I still had available. If I went over, I already knew I would be dropping frames. I don't do any double buffering on the tiles. There is no character scrolling and no animation with characters, except for the stars and the grass, which are falsely animated by modifying the definition of a handful of characters. The characters are initially pre-positioned in order to create the parallax effect.
Now let's get to the enemy management and the mathematics. Obviously, the balloons move in wavy patterns, as we can see here, using pre-calculated sign value tables. And what I'm saying is that managing the enemy logic with projectiles entirely in C, in fact, puts a heavy load on the CPU. So let me ask you, did you have to make any compromises or specific optimizations in the code to actually keep the code running smoothly?
C is fast enough, and as I said, I use pre-calculated sinusoids. Optimal code, well written in C, which is not the case for my game at the moment, will run on average at 50% of the speed of optimal assembly. C is very close to the hardware. To make it run well on 8-bit systems, however, you need to use some tricks. I have documented some of the tricks to use, not just for the C64, here.
As we can see from this page regarding the library, specifically the sound library, the audio management is quite interesting. The music is in assembly on an interrupt, but the sound effects are triggered from C writing directly to the SID registers, often stealing what is channel 3. I ask you, did you encounter any synchronization problems or audio glitches by having the two parts interact in this way?
No conflict issues, but the code isn't perfect due to lack of time and my limited familiarity with the SID. There are some glitches that are easy to fix. The SID tune code is disabled with a flag, but at that point, you have to save the state of all the SID registers and then restore them when the music is re-enabled. My excuse is that I release a version of this game every year between January 5th and 6th, and I develop it between Christmas and New Year's. If I can manage it, BEFANA vs Balloons 2027 will have better sound effects.
Let's go back again to the library. So you are very well known for the cross library that allows you to port games to dozens of retro systems. BEFANA was created specifically for the Commodore 64, taking full advantage of its hardware, sprites, and SID. Or is it a project that we might see in the future ported to other machines through your libraries, and therefore not just for the Commodore 64?
Yes, it could be, but not with crosslib, because crosslib, wanting to cover more than 200 different machines, uses a tile-based abstraction and therefore doesn't have sprites, other than software sprites simulated with tiles. I also released a version of BEFANA vs Balloons 2026 C128 Enhanced, which uses 2 MHz on the borders when it runs on a C128 in 64 mode. I could also make a native C128 version. If I ever find the time, a version could be made for machines with many hardware sprites. For example, a version could be made with a single C source code for all machines with the TMS9918A graphics chip and its derivatives, like the TI-99/4A, MSX, Creativision, Spectra Video, Sega SG-1000, Sega SC-3000, Memotech MTX 500, 512, etc.
Let's go back to the initial screen of BEFANA. After the experience with this game, I'll ask you about the future. Do you have other projects in the works for the Commodore 64, maybe another game that pushes the multiplexer even further, or something completely different?
Probably a future exclusive game for the C64 and or C128 could be a minigame that can be developed in a few days. Crosslib takes a lot of time. I'm not promising anything, but I'm thinking about it.
Well, what can I say? Befana vs Balloons, written by Fabrizio Caruso, 2026, new version, most likely in 2027. I thank Fabrizio for giving me the opportunity to bring this great topic and this great game to the channel, and especially a know-how and knowledge that can surely help others in producing games by looking directly at the source code he has released on his GitHub. What can I say? Thanks to everyone for staying with me up to this point. We'll see you next time on Project CD Chronicles Claudio.